Hello and good day. For the first time ever, we are actually recording our, I'm going to put my marker back, our going over of the math packets, but I can't do anything until I find my green marker. Where did I put my green marker?
I don't know.
It's not my shirt. It's not my, oh, here it is. Okay. Anyway, so we'll put this back. We'll scroll down. So we're going to talk about math packet number 4. Kind of go over the, give you some hints on where to start, just like we always do with these questions. So remember, you can turn these in early for me to check over. I recommend that you do it. I'll either kind of say you're close, just look at it in this way, or if things are completely off, then I'll put you down the right path. So the first one here, Judy listed a fifth number with the set of data 3, 6, 7, and 10. The number she included made the mean of the 5 numbers equal to their median. What number could Judy have included with the data? So the key here is that the mean is equal to the median. Okay, just as a reminder, what is the mean of a data set? The mean of a data set. Ifan. Right, it's another word would be average for it, but it's the sum of all the data divided by how many there are. Okay, and then how about median? What's the median of a data set? Connor? Sorry? The middle number when, not when there's an odd amount, but when something with the numbers themselves. When they're ordered from least to greatest, okay? So far we have 3, 6, 7, and 10, which are ordered from least to greatest already. So really, and I'll give you a little bit of a hint here. We're not talking decimals. We're not talking fractions. So whole numbers only. There's only 2 possible things the median of this set could be if you add a fifth number to it. Anybody see what those 2 possible medians could be? Yeah. Sorry? 7 is one possibility, right? If you add an 8 or a 9 or an 11 or 12 or whatever, that would make the median 7. Or the median would be 6 if you add a 5, a 4, or a 2, or a 1. Okay? So essentially what you're looking for here is you're looking for a fifth number that will make the mean either 6 or 7, because those are your 2 possible medians. Okay? You're looking for a fifth number that will make the average here of then those 5 either 6 or 7, because that's what your median is going to be. If you add a number greater than 7, your median will be 7. You're looking for an average of 7. If you add a number less than 6, you are looking for an average of 6, because the median will be 6. Okay, so it's kind of nice to know that you really only have kind of 2 options here for that median, and that can help you find a number that's going to give you that equivalent mean. Okay, questions on this one? Other questions on this one? No. Okay. Moving on then, down to the second logic question. It says, on a recent airline flight, there was 1 empty seat for 3 passengers. Obviously, this was written pre-COVID. 1 empty seat for every 3 passengers. If there were 132 total seats on the plane, how many passengers were on the flight? Okay. What should you be thinking about the number of empty seats and filled seats in groups of? Like that first line there. A recent airline flight, 1 empty seat for every 3 passengers. What is that a group of, Aiden?
Division?
Sorry?
Division?
I'm not asking for an operation here, but what group size is that? 1 and 3 for a group of 4, right? Essentially what this line is saying here, 1 empty seat for every 3 passengers, is that in a line of 4 seats, okay, you've got 3 that are filled and 1 that is left open. So if you think about that in groups of 4, and Aid mentioned division, which is also going to come and play a role here. if there are 132 total seats on the plane, if you think about those in groups of 4, where for every group of 4 seats, 3 are filled, 1 is empty, that's going to be a real slick way to answer the question of how many passengers were on the flight. How many seats of those 132 available seats, how many were filled? How many passengers are actually on the plane? That's what you're trying to get to here. Okay? But groups of 4 is a good way to think about that. Questions on this one? Okay. Then we move into the 5-card challenge, I believe, which we've done a few of these now. Just remember, you are going for 15 total points. Oh boy, this one is an interesting one. Remember how last time we talked about how important having a 1 is? Right? You can do a lot of things with a 1. You know, you can multiply, not change the value, divide, not change the value. There are actually kind of 2 1s given to you here. The first one is the ace. That one's pretty obvious. But what's the second 1 that's kind of provided for you in those 5 cards? Alexis? The 2 4s, right? 4 divided by 4 is equal to 1 also. So I'm looking at this, and this is, I'm not going to, no, that would give you all 15 points. I'm not going to say that. But know that, you know, when you multiply or divide something by 1, it doesn't change the values. That's pretty slick. And you've got a 1 as an ace that you could use, and you've got 2 4s that you can combine to create a 1. Okay? Aiden.
What do these have to equal again?
You have to use the top 5 cards to total the card on the bottom. So all of your equations have to equal 3. Okay? Questions on that one? 5-card challenge. Get your 15 points. That is the goal. That is the goal. All right. Perimeter area. So the first 3 packets were primarily rectangle shapes. They were irregular shapes, but rectangular shapes. Here we introduce that curved side, that semicircle. Okay, that semicircle. And like the others, we're looking for the perimeter in the area. Now, the perimeter of this figure does not include that dotted side, or not side, that dotted line there. That's just kind of giving you a measurement that you need. The perimeter of this shape is the 3 sides of the rectangle here, and then the distance around this curved side there. Okay, what I've highlighted in green is the perimeter. Now we know that the perimeter of a rectangular shape is just add the sides together, but circles don't really have perimeter. They do, but we call it something else. What's the distance around the outside of a circle called? Circumference. Does anybody know what the formula for circumference is? I heard someone say pi, that's part of it. What do you do with it?
R squared.
So pi r squared is area, which we will need to use that when we find area, so hold on to that one. But how about for circumference? Pi times, Yvonne? You can get there with the radius, but it's easier to get there with the diameter. Okay? Pi times d, pi times the diameter, is the formula for the circumference of a circle. And when we talk about this variable d, we are talking about the diameter. What is the diameter of a circle? What is the diameter of a circle? Aiden?
Perimeter of a circle.
No, the perimeter or the circumference is, you can use the diameter to find it, multiplying it by pi, but the diameter of a circle is specifically the distance across from one side to the other through the center. So that dotted line that I said wasn't a side of the figure, but we would use it. That dotted line represents the diameter of that half circle. Right? That's the diameter of that half circle. So if we use this pi times d, that's going to give us the circumference of a whole circle. Do we want the circumference of a whole circle here? No. We want the circumference with half a circle. So when you multiply pi times the diameter, what are you going to do with that value to get the circumference of the half circle that we have here? Come on. Divide by 2. Okay? So the actual formula for circumference is pi times the diameter, but based on what we have here, you're going to have to divide that by 2 to get the circumference of this half circle. So the divide by 2 isn't part of the original formula. It's a manipulation that you need to do based on the context here. Okay? For area, right, you can kind of separate this shape. I'm going to erase these outside lines here. The diameter kind of separates the shape into the semicircle and the rectangle. So we've talked about the formula for the area of a rectangle before, right? This is going to be base times height. Nothing new there. And Jacob mentioned before that pi r squared. That pi r squared is the formula for the area of a circle. Okay? And what does the r stand for? What does the r stand for? Lucas? The radius. What's the radius of a circle? What's the radius of a circle? It's half the diameter, essentially, because it's from the middle to the edge is the radius of a circle. I should not point to diameter. I should do radius. Okay? And you are squaring that value and then multiplying it by pi. Order of operations here, right? That exponent comes first before you multiply by pi. You're squaring the radius and then multiplying it by pi. But do we want the area of a full circle, which is what that formula gives us? No. So again, what are we going to have to do here to get that area of half of that circle? If that formula gives us the whole thing, but we only want half of that, what are we going to need to do? When we only wanted half the circumference, we divided by 2. So why wouldn't we do that with the area? We only want half of it, right? Whenever you want half of something, that's the definition of dividing by 2. Okay? So again, similar to the circumference, when you get that area of what the full circle would be, you're going to want to divide that by 2 to get the area of half the circle. Okay? So the area of the rectangle, base times height, and the area of this half circle, pi times the radius squared, but then you're going to have to divide that by 2 because you only want half of the circle. Whenever you deal with pi, expect decimals, right? Because pi is an irrational number in and of itself. So just round your decimal answers to nearest hundredth. Okay? Round decimal answers to nearest hundredth. Questions on this one? Kind of a new frontier in introducing circles here. Anything? No? Okay. On to the next one. Is it our pattern question? Oh, look, I figured out how to scan in color. Aren't you proud of me? It's a button on the printer that says color, and I found it. It was kind of hidden, the first 3 packets, but I did it. Okay? Okay, so for this one, similar to what we've had before, we've got the first 4 figures, and we're increasing the size of the figure in a sort of pattern. Okay? Last packet, we had 3 colors being added in a triangular shape. In this packet, we've got 3 colors that are being added in a rectangular shape. And your job is to complete the table for the number of blue blocks and total blocks in each figure. Blue blocks and total blocks. If you also green and red, that is fine. If you get answers wrong in the green or the red section, I'm not going to take points off. I'm only going to be actually grading the blue and the total block. So let's figure out what we know here. Okay. Number of blue blocks in the first figure? 1. And then the number of total blocks in the first figure? Also 1, right? There's only 1 block there. Second figure, still 1 blue block. So again, we see here that, not every color is being added every time. We actually don't increase the number of blue blocks until figure 4. And we go from 1 blue block to how many total? How many total, Annika? 14. We add 13, but including our original 1, we have a total of 14. How about total blocks in the figures? We go from 1 total block in figure 1. How many in figure 2? Anybody? 6. How many in figure 3? 15. How many in figure 4? It's not 35.
29.
Not 29. Samara? 28. Okay? So the goal of this here now is to look for some sort of pattern, right? 1, 6, 15, 28. Anybody see any pattern we can use to help us predict? Because these figures are getting pretty big fairly quickly. I don't want to have to draw figure 5 out, but anything you can see. Samara? Sorry?
When you're looking at the block, I don't know if this is on the vertical side, it keeps going up by 1, but on the horizontal side it goes up by 2.
Okay. So Samara's noticing here that the height of each figure, that vertical side, is going up by 1. In the second figure, we have 2 blocks going up. The third figure, we have 3 blocks going up. The fourth figure, we have 4 blocks going up. I'm just going to draw figure 5 here. I know it's going to be a rectangle there, but how many blocks will we have going up? What will the height be of figure 5? Following this pattern, even figure 1 has a height of 1 block. So 1, 2, 3, 4, figure 5 will have a height of 5. And then going a little bit further, Samara is saying, well, if we look at the base or the horizontal of each rectangle, we're starting with 1 for a 1 by 1, then 3 for a 2 by 3, then 5 for a 3 by 5, then 7 for a 4 by 7, 1, 3, 5, 7. What will the base be of figure 5? Ethan? 9. And so how many total blocks will be in figure 5? 45. 5 times 9, right? Samara, that was brilliant. How about figure 6? What will the height be of figure 6? The vertical distance of figure 6. It'll be 6. Okay. What will the horizontal, the base be of figure 6? Following this pattern. 11. Up by 2 again. And so how many total blocks will be in figure 6? Alexis? 66. All right. I like it. Right? The height is increasing by 1 every single time. The base is increasing by 2 every single time. So if you just want to, rather than drawing out all these rectangles and filling in the values like you have here, maybe you just want to go down the side of your chart here and just say, 1, 2, 3, 4, 5, 6, representing that height. And then you're going to be multiplying that by 1, by 3, by 5, by 7, by 9, by 11, right? That's kind of what we did there to get these totals so far. And just continue that pattern down the side there to get the total blocks. And then as far as the blue ones, well, we know we're going to stay at 14 for the next two shapes because we're not going to change, we're not going to get more blue until figure 7. And then you got to kind of figure out, well, how many are being added, okay? And I'll let you kind of take a look at this and say, well, how many blocks of each color are being added from figure to figure, and then get that pattern developed there. But nicely done so far with those total blocks. There's definitely something going on there. Okay? Good, 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 good. Anything else with this one? Okay. The next one. So this one, I call it a right rectangular pyramid. It's really just a pyramid. I copy and pasted from the volume page because usually those shapes are the same, but for some reason this one isn't the same. So it is a pyramid, but it's not a right rectangular pyramid. So you can just cross those two words out. But like the other ones, you need to draw a net of the figure and label each side. Okay. The drawing of the net and the labeling each side, on your last math packet, a lot of you underline that, like I just did here, but then you didn't do it. Okay. Either you drew the net, which on packet 2 anyway, looked kind of like this, and you just kind of left it like that, right? You drew the net, but it's not labeled. You have to label what each side is, what its measurement is. And my reasoning for doing that is it is going to help you with calculating surface area and such as that. Because you see what shapes you have there, you know the formulas for area, and you can apply them to it. So the net of this, what shapes do we have here? If you were to unfold that pyramid and lay it flat, right? What shapes are involved? Aiden?
A square in the middle and 4 triangles.
Yeah, a pyramid's kind of easy to visualize, flattened out. You have that base square in the middle, and then the 4 triangles, the 4 flaps, just kind of fold out beside it. Okay? So you got this, that, that, and that, right? Isn't that pretty? Okay, it's like a star. And as far as labeling goes, well, each side of the square we know is going to be 8. So I'm going to put my 8s in there. And since I'm dealing with surface area, that the area formula for a triangle is what? We've worked with this before. The formula for the area of a triangle is what, Aiden?
Base times height times width divided by 3.
You're going into volume here because you're multiplying 3 things together. The area of a triangle, Ifan? 1/2 times base times height, or the different formula does the same thing. Base times height divided by 2. Either one works. Okay, but this 16 feet here, that represents the height of the triangle. Because remember, like this here that I'm outlining in green, that's like this diagonal side of that figure. We don't use that when calculating area of a triangle. It's not the diagonal side, it's that vertical segment connecting the base to the top of the triangle. So in each of these, we're not labeling that diagonal side because we don't use it for surface area. We've got the height there, that vertical segment connecting the base to the top of the triangle, and in each of them it is 16. Okay? So there's your net with sides labeled, actually. Spirit of Christmas, it's all there for you. Your job now is to calculate the surface area. What's the area of all of those surfaces together? That 1 square and 4 triangles. Annika.
Doesn't there have to be like, oh wait, never mind.
Good? Okay. Anything else with this one? All right. Next This next page is probably volume, if it's in order. Yes, it is. And so here we have a right rectangular pyramid. And what makes this a right rectangular pyramid is that, first of all, notice the base is a rectangle, right? It's got two different lengths for its base and width there, 10 and 8. It's not a square. They're not all the same. And it's a right rectangular pyramid because this dotted line in the middle is going from the tip of the pyramid directly down to the middle of the base and forms a right angle, thus the right rectangular pyramid. And the formula for the volume of a right rectangular pyramid is the length times the width times the height divided by 3. Or another way to write that is base times the width times the height divided by 3. Okay. Think about a pyramid being kind of cut out of a cube, you know. The volume of that pyramid will be 1/3 of the volume of the original cube, which is why base times width times height is the volume for a cube. We're dividing that by 3 because that pyramid is going to be 1/3 of that. So the calculation that we'll perform to find the volume of this specific pyramid, okay, we've got the length, 10, times the width, 8, times the height, 6, which is why that straight vertical segment from the top down to the base, that 6 is important here. That's the height, and we're dividing that by 3. So 10 times 8 times 6 divided by 3. Who's got it? Aiden? Well, 10 times 8 times 6 is 480. What's 480 divided by 3? G? 160. You can also think about that as 48 divided by 3, which is 16, and then just tack that 0 on there. Okay? But 160 cubic inches is the volume of this pyramid. Base times width and height divided by 3. Your question in pre-algebra here, how many faces, edges, and vertices does the figure have? And just keep in mind that the height of the pyramid, this dotted line, this green one here, is not an edge of the pyramid. It's inside. It's just a measurement to help us find the volume. So faces would be like surfaces, right? We did that in surface area. It's got 4 triangles, 1 square. Edges would be kind of like the sides of this. How many total edges does this have? Including these dotted ones behind it that are there, but you can't see them. That's why they're dotted, but not the height. And then how many vertices? What's a vertex, which is the singular form of vertices? What's a vertex? You heard that word before? We heard of vortex, right? The polar vortex that we get every year that makes it really cold for like 2 weeks at a time. But a vertex, Pierce? It's all the corners, all the points, right? All the points where those sides intersect. So the total number of faces and edges and vertices. Okay, don't add them all together, but how many faces, then how many edges, and how many vertices. Okay? That's your job there. And then we move on to our math exploration, still looking at Pascal's triangle here. And we're looking for the relationship between rows and elements. Okay? So down the left side here of this triangle, you are writing the row number, and that first row, that's just a 1, is called row 0. It's considered row 0. So row 1, row 2, row 3, row 4, and you can see why that top one is called row 0, because now we can look and say, our second element here is a 4, it's row 4. Our second element here is a 5, this is row 5. Second element is 6, it's row 6, right? So it starts with that very top point being row 0, and then just 1, 2, 3, 4, 5, 6, and so on and so forth. Okay? Then on the right side, you're going to be writing the sum of the elements, and the elements are the individual numbers within that row. So row 0, 1 is just itself. Row 1, 1 plus 1 is 2. Row 2, 1 plus 2 plus 1 is 4. Row 3, 1 plus 3 plus 3 plus 1 is 8. Row 4, the sum of those is 16. Row 5, we get 32, and so on. Okay? And kind of like our pattern block page, you're looking for patterns here, right? You know, the 4 questions that you need to answer, the first one, what relationship exists between the sum of any row and the sum of the row before it? So if you were to pick out any 2 rows here, what's the sum of row 4 compared to the sum of the row before it, row 3? Or what's the sum of row 5 compared with the sum before it in row 4? Question 2, following this pattern, what is the sum of row 11? So you go all the way down to row 10, right? And once you identify the pattern of the sums as you go down the triangle, you can then predict, without having to actually draw it out and add them all up, because the numbers start to get pretty large here, what's the sum of that next row going to be using that pattern? Then number 3 says, what is the relationship between the row number and the sum of the elements in that row? This one's a little bit harder, okay? We had 8, 16, 32 here. So now what you're looking for is, what is the relationship between the row number and its sum? What is the relationship between the row number and its sum? And your hint for that one, it's a powerful hint. Get it? It's a powerful hint, because the hint is exponents. Okay. Think exponents. Okay. Think powers. And then once you find that pattern, then number 4, following this pattern, what is the sum of row 16? Okay. So 2 patterns that you're trying to find here. What is the pattern in the row sums as you go down the triangle, and then what's the pattern of the row number and its sum as you go across? And then use those patterns to predict future results. That's what patterns do. That will predict future results. Okay, and then the last one, I believe, is your polynomial question. I tried to make a T. Came so close. But where in that figure are each of the 8 polynomials that you have? Just a reminder, and you folks do really, really well with this section. This one is always a high scoring area. Just make sure you are not rotating or turning any of the shapes. The way they appear on the left here is exactly the position in which they appear in the figure on the right. And use these clues to help you. You know, just looking at this, it's impossible for these figures to appear anywhere in the stem of the T, right? Because they go 3 across, each of those figures do, and the stem only goes 2 across. So, like I said, there's certain tricks, certain logical conclusions you can draw that helps you place this, and that would be one of them. And look at that, we are exactly out of time. Wow. All right, due in 3 weeks. Turn in early for me to correct if you want. We'll go over homework tomorrow. That is how you math. Have a nice day, folks.